Yes. So solving these, so most problems have your variables x, y, and z. It doesn't have to be x, y, and z, just like it's not always x, y, it could be a, b, c, or whatever it is. We are not solving these by graphing. I'll talk about why, but I still want, or as we go through examples, I'm still going to talk about what the graph would represent. Because again, what the graph represents, that's really what your solution is. So I have on here, just like systems of equations in two variables. So if you only have two variables, x and y, you need two equations. When you add a third variable, you need three equations. But a system in three variables is going to have one solution. So exactly one, an infinite number, so infinitely many, or it might have no solution. And if it does have exactly one, the solution is an ordered triple because you have three variables. So it's an ordered triple x, y, z. So it's not like the two-dimensional coordinate plane that we are usually graphing on where you have ordered pairs x, y. This would be a three-dimensional graph. You have a z-axis as well as an x and y. So we're not graphing these. If you graph the equation or graph an equation that has three variables, you are graphing a plane. So these equations represent planes, not lines. So the graph of a system of equations in three variables is a system of three planes. So to think about this, if you have one solution, we are all clear, the stop lockdown is complete. We are all clear, the stop lockdown is complete. Thank you. So if you have one solution, your three planes are intersecting at one point, one ordered triple. If you have infinitely many solutions, there's a few things that could be happening. It either means, like if picture three sheets of paper as three planes, it could be that all three planes are the exact same, so they intersect at every point on the plane, or it could be maybe two of them are the same, and then you have another plane that's coming down and intersecting to form a line, which then there's infinitely many points on a line. So that could be the case for infinitely many solutions. No solution just means that all three planes don't intersect. So all three planes do not intersect. It could still be that two of the three planes intersect each other, but all three do not. So two of the planes are parallel to each other because at least two of the planes would not intersect. Or it could be that maybe all three are parallel, so none of them intersect each other. You might still have an intersection, but it's not with all three. So we will go through examples where you get one solution, infinitely many no solutions, so you can see how that looks. We are not solving these by graphing. We are solving these using the substitution and elimination that we used with systems of two equations. Because you have a third variable, it does add additional steps that you have to do. So I have this broken down in example 1. These are the three overall steps, but even in between these three steps or within them, you have multiple steps. So it's just very important that you not only understand the steps, but you keep your work very organized so you know what you're doing. So to solve a system, you don't have to. I'm just going to, for purposes of going through these together, I'm just going to label these equations 1, 2, and 3. And all three equations have all three variables. Step 1 is to eliminate one of your variables. You're eliminating x, y, or z by using two pairs of equations. So you're eliminating x, y, and z by using two pairs of equations. And so I'm going to start out I just picked two of my three equations to start. So I'm going to pick equations 1 and 2. I don't want you to miss this lesson because this is brand new. This wasn't in Algebra 1. So I'm going to pick equations 1 and 2. I'm just going to rewrite them here. And with these two equations, I need to pick one of my variables. I'm going to use elimination. I need to pick one of my variables to eliminate and then do the appropriate steps to eliminate that variable. So you might need to multiply one or both equations by something. Remember, elimination is when you add the equations together, you want one of the variables to become 0. So somebody pick X, Y, or Z, which would you eliminate, and then how would you, okay, Z, and then what do I have to do to get Z to eliminate? Multiply the second equation by 2. Okay, so I'm going to just rewrite this. My top equation is staying the same. And my bottom equation is now going to be 4x plus 2y minus 2z equals 10. Okay, but if I add these together, my z's do eliminate. 2z plus negative 2z is 0. And then I add the resulting like terms, so I get 9x plus 5y, bring down my equal sign, and then 12. Okay, and then I'm saving this. I'm not done in step 1, but I'm saving this for step 2. I'm going to need that equation again. Now, what this means also, again, these two equations are planes. So these two planes, since I got this equation, intersect to form this line, is what that means. These two planes intersected to form this line. So now, because it says two pairs of equations, I picked equations 1 and 2. Now I have to pick a second pair, and one of my equations has to be equation 3. I have to use all three. So I pick either 1 and 3 or 2 and 3, but I have to eliminate the same variable. So since I eliminated z here, I have to eliminate z again. So if I look at equation 3, knowing I have to eliminate z, I would pick whichever one would be easiest to eliminate z. So I guess either way, it's really not that big of a deal. I'm going to pick 1 and 3. But if you notice that picking 1 makes it easier to eliminate your variable, you'd want to do that. And so I have to eliminate z again. I could just subtract the equations to eliminate z, but I'm going to multiply the second equation by negative 1 to eliminate it. So my bottom equation would be negative x minus 4y minus 2z equals negative 16. Okay, so my z's eliminate. And then if I add everything else, I'll have 4x, a negative 1y, so minus y equals negative 14. So that means, again, planes 1 and 3 also intersected to form a line, and this is the line they formed. Okay, so now you have two equations that have the same two variables. And now these equations you put together in step 2, and it says solve the system of two equations. So I take these two equations, the 9x plus 5y equals 12, and the 4x minus y equals negative 14. Okay, but I'll draw arrows. This is where those are coming from. And now I solve this. So now it's like I have a problem from 3.1. You can use elimination or substitution, but you solve this to find both x and y. I would, just given how it's set up, I would use elimination. I would probably eliminate the y. What do I have to do to eliminate the y? Bottom one, multiply by 5. You might have to multiply both equations no matter which variable you choose to eliminate. So I'd have my top equation stay the same, and my bottom equation, 20x minus 5y equals negative 70. So my y's eliminate. If I add everything else, I get 29x equals negative 58. And now I'm at a place that I can find x. So if I divide by 29, I get x equals negative 2. Okay, so I have 1/3 of my answer. I have 3 variables to find. I know one of them. And now I'm still not done in step 2, because if I know x, now I can go back to either of these 2 equations to find y. I'm going to use, I'll use the second original equation. So if I put negative 2 in for x, I'd have 4 times negative 2 minus y equals negative 14. So negative 8 minus y equals negative 14. And then if I add 8, I have negative y equals negative 6. So if I divide or multiply by negative 1, y is positive 6. So now I have 2/3 of my answer. Yep, so now step 3 is take those 2 values from solving that system and go back to one of the original to find z. And it does not matter which one you plug it into. I'll just use the bottom one here. You should. It should not matter which one you plug it into. As long as your x and y are correct, no matter which one you plug it into, you should get the same z. So I'm plugging it into the third one that was in the original. So I have negative 2 plus 4 times 6 plus 2z equals 16. So I'm going to combine these right away because that's negative 2 plus this is 24. So I'd have 22 plus 2z equals 16. Subtract 22. So 2z is equal to negative 6. And then divide by 2. Z should be negative 3. Okay, now just like with systems of 2 equations, I said to write your answer as an ordered pair. Here you write it as an ordered triple, and it's x, y, z. So these 3 planes intersect at one point, and that's at negative 2, 6, negative 3. Okay, now if I went back, say I wanted to check my answer, since I used equation 3 to find z, quiet please. Guys, I feel like I'm having to talk over a lot of separate conversations. Whether you're answering questions about this or not, it's still, you're missing other things I'm saying, and it's distracting to me, and I already know how to do this, and I'm distracted. Okay, so to check this, I could go back then to equations 1 and 2, since I already used 3 to find z. I could plug in x, y, and z into both equations 1 and 2 and make sure that it works out. So you can still check your answer like you could if you had just 2 equations. So when you substitute these 3 values into all 3 equations, it should work out in all 3 of them. And if it doesn't, something's wrong. Okay, there's a lot of steps. There's a lot of places you can make a mistake. You forget one negative somewhere and you're done. You have a mistake somewhere in there. So that's why with these, It's important to keep working through it. If you realize somewhere you're getting stuck, something doesn't make sense, and you can't find your mistake, sometimes the best thing to do in these is literally just start over. Just say, okay, I need to get rid of what I just did and start again. I'm thinking ahead for your quiz or your test. If you have one of these and you're getting stuck, something's not working out, just start over if you can't find where your mistake might be. But that's why the practice is very important. These don't become easier if you're not practicing them. Well, working through it right now might take you 10 minutes. If you practice it enough, it shouldn't take you 10 minutes. Well, but if you haven't practiced it at all, then on the quiz, yes, it's going to take you a long time. You have a class period for the quiz. Okay, so it's important that you practice it. So here's, I have two others. That's one solution. Here's what it looks like if you get infinitely many or no solutions. So if I start the same way, I have three equations in number 2. Step 1 is take two different pairs of equations, eliminate a variable. So let's say I pick equations 1 and 2. Okay, somebody pick a variable to eliminate, x, y, or z. Okay, I heard x first. What do I have to do to eliminate x? Yeah, multiply on the top by -3. So I'd have -9x plus 3y plus 6z equals -12. And my bottom equation I'm not changing. So I wanted to eliminate x, which I have done, but the y's also eliminate, so do the z's, so do the 12's. So this is 0 equals 0. In systems of two equations, what did this mean? The infinitely many, because this is true, 0 equals 0. Here, we're not done. You cannot say there's infinitely many solutions to this. This means that these two planes, so the planes that I chose, planes 1 and 2, are the same. Their solution set is infinitely many. They are the same exact plane. You don't know what plane 3 is doing. You don't know if plane 3 intersects these two. These two are the same. You still have to know what's going on in plane 3. So I still have to do, we're still in that step 1, I still have to pick another pair of equations, use equation 3 with either 1 or 2 to see if it is infinitely many solutions or if it's no solution. So if you get this in your first step, it is either going to be infinitely many or it's going to be no solution. Those are your two options. So right now I know that there's not just one solution. My answer is either infinitely many or no solution, but I have to know what's happening with plane 3. So I'm going to pick, I know everything canceled, but I started out trying to eliminate x. So if I want to eliminate x again and I have to use plane 3, I would choose plane 1 and 3 to eliminate x. So I have 3x minus y minus 2z equals 4, and then 6x minus 2y minus 4z equals 11. So again, if I wanted to continue, I had chosen to eliminate x in the other one. Here I'd have to multiply the top by -2. So I have -6x plus 2y plus 4z equals -8. And then my bottom equation is not changing. Okay, so my x eliminates. But again, so does my y, so does my z. My constants do not. So I get 0 on this side and then 3 on this side. So this is no solution. This means planes, I chose, let's see, 1 and 3. 1 and 3 do not intersect. They are parallel planes. So if planes 1 and 2 are the same and then plane 3 does not intersect them, all 3 planes do not intersect. So this is no solution. So either writing no solution or the empty set symbol, either one's fine. You might. Well, you might. It could be. I wouldn't go through it if it couldn't be on your test. Right? So it's only if this is your first step, you have to do the next part to determine if it's infinitely many or no solution. If you did this part first, you can already say it's no solution because you already know 2 of your planes don't intersect, so there can't possibly be a solution. Okay, so if this was first, you'd be done. It's only because that was first. So if we look at example 3, I'll just ask you, somebody pick 2 equations. The first 2? 1 and 3. 1 and 3? Okay, so I'll do 1 and 3 first. Equations 1 and 3. Pick a variable to eliminate. Which variable would you eliminate? X? What do I have to do to eliminate x? Yeah, bottom by -2. So top is staying the same. And then -2x minus 4y plus 8z equals -14. Okay, so x eliminates, nothing else does. Okay, so I get -3y plus 5z equals -9. One and 2. Okay, so I have to keep going. Equations 1 and 2. So 2x plus y minus 3z equals 5. 6x plus 3y minus 9z equals 15. So again, I eliminated x here, so I should be trying to eliminate x here. Multiply the top by -3. I'm just going to write this equation below it here. So then that equation becomes -6x minus 3y plus 9z equals -15. Okay, my x does eliminate, but so does my y and my z and my 15s. So I get 0 equals 0. So this one, now this wasn't my first step. So here I can say there's infinitely many solutions, but this is why. Okay, this means planes 1 and 2 are the same plane. Okay, 2 sheets of paper. These planes are the same. Then planes 1 and 3 intersect to form a line. So this is 1 and 2, and then plane 3 is coming in like this. So it's intersecting both of them, but the intersection is a line, and there's infinitely many points on a line, so it is infinitely many solutions. So if 2 of your planes end up being the same, then like I said up here, it's either infinitely many or no solution. This intersection being a line means there's infinitely many solutions because it's every ordered pair on that line. Okay, questions there? So these can be tricky with the 0 equals 0, just making sure that you're the right answer, infinitely many or no solution. Otherwise, you actually get one solution. you should get a value for x, y, and z, or whatever your variables are.